All right, welcome back to episode 59, Separate Little Languages. So I had an awesome conversation in our Knoxdev Slack a couple days ago with a local developer, and we were chatting about different things. We've got quite a few people who are getting really, really hyped on functional programming, and rather than let whatever I'm going to call it information, I'll let you decide whether it's has any value of it. But I wanted to take some ideas that I had there that I put out on the Slack channel, and hopefully let them live on in YouTube format. So this concept of separate little languages. So Ramda and a lot of other libraries, but it had this concept of head, and so we can do the head of a list of 1, 2, 3. Of course, we get 1 back because that works. But if we call head on an empty list, we get undefined. Now, in a pure language, we're not going to have the concept of undefined. So what if we were in a language that didn't have null or undefined or any of the other nil or whatever language you're working with, but it doesn't have the concept of something that's nothing? In that case, what you would have to do is you'd have to start working in the maybe language. So this maybe language can live, you can use that call into that maybe language from your pure language. And what that would allow you to do then, maybe in this case, is actually a larger language. Because if our language doesn't have this concept of undefined, we've got this concept of something exists, but we don't have this concept of something that's undefined. What we need to do is we want to expand the current language that we're working in. And a way to do that, in this case, is to bring in the maybe language. And the maybe language allows us to do things like saying, if there is a value in this array, then we return maybe of that value. And if it's not there, then we can say maybe nothing. So there's nothing here that we have we can use because we're in a bigger language, a language that has more features now when we're in this maybe language. And what that allows us to do, obviously, if we call maybe head on this, if you've seen any of these videos, this is nothing new here with what we're able to do with maybe. And here we get our nothing. We still haven't even dealt with undefined. We're still pure, but we've added on this maybe language that we can deal with. And so this seems to make some sense. And maybe, as we know, it's a functor, and it's an applicative, and it's a monad, and it's all of these other things. But maybe is different. So when people will tell you, or you hear someone say, oh, you should use the maybe monad, or you should use the IO monad, or the future monad, or whatever. That was really, really confusing to me when I started. I was like, a monad is a monad. And while that's true, this is kind of what they're talking about here, is dealing with increasing your current language by adding a new language on top of it, like maybe. So here's another example. In a pure language, we can't do anything like this. Because console log, that's an effectful computation. And if all of the effects in the language you were writing in were managed, you wouldn't be able to do this. But to write a program that's going to have any real value to anyone, you need to let them know what the output of the program was, probably. Well, not probably. Otherwise, the computer might get warm and the fan might start spinning. But other than that, you don't know that anything's actually happening. And so what we could do is we could bring in the IO language extension. And what the IO language extension would allow us to do is to perform side effects. But those side effects are handled in the IO language. They're not handled like this in our regular language, because we wouldn't even be able to do this. We could only do something like this if we were in the IO language. And so what we could do is we could mark that this code here is in the IO language. So here's IO. This is the stuff inside this language. So anything within here is happening in the IO language. And so what we can do is we can have this log IO function, which takes a string and returns an IO. We can absolutely do this, and as it turns out, this is an IO of unit, because this actually doesn't return anything, but we can call log IO, and we can pass hello. But you notice that the result here is an IO, because we're in the IO language now. We're dealing with IO. we're not dealing with things that can write to the console like this does. You see our little blue quotes here, and we have no blue quotes here because nothing was logged. No logs were harmed during the execution of this call. So that may help you as a different way of thinking about all of these contexts. Part of the idea where I came from some of this is teaching some high schoolers how to write some software, and they're one of the things they have to do is it has to be in PHP. Well, in PHP, one of the things is in one PHP file you can have HTML, you can have CSS, you can have PHP, you can have all of these different languages. If you put your MySQL code or whatever inside of a PHP thing, you get like 5 different languages. And the important part to think about is which language are you in at the time. And that's what's happening with a lot of this. In another way you could say this is, if this is our entire app, what we've done is we've lifted our entire app, which in an impure language would just be console log s. We've lifted that into I/O. So now our application is inside of that I/O language. So I hope you enjoyed this. A little bit less code today, but maybe it's a cool way of thinking about it. Let me know, do you like this idea or not? Thanks so much for watching, and I hope you had a good time. Episode 59, Separate Little Languages.